Hello, everybody, and welcome to Cram season with Fiveable for AP Stats. We are super excited that you're here for our first preview night. And as you can see there on the screen, we have our dates for our actual Cram sessions posted, May 2nd through 6th. That's the 5 nights leading up to the exam. So before we really jump in and get into things, just some community agreements that we have here at Fiveable. Number one is to be supportive, make sure that you are lifting each other up. We are all in this together in this AP season. Students, teachers, all of us are working hard towards that AP exam day. So let's be supportive. Let's also be patient with each other. We have the 2 preview nights and then also the 5 nights that we have together. So let's be patient with each other if we have technology issues or if people are asking questions. And, this is a community where we are all learning together. So be patient with each other and be patient with us as well. Also be kind. We have some wonderful student hosts and student designers that have put all of this together. And they are going to do an awesome job. And I'm super excited to see how everything pans out, but let's definitely all be kind to each other along the way as well. So the way that I think you can make the most out of this preview night tonight, the first thing is to take notes. As we are going along, make sure that you are taking notes along the way. That's going to help you to not be on your phone, not be checking Facebook, Snapchat, Instagram, whatever, and be totally focused on what we're talking about and taking notes along the way. Also, in your Fiveable account, you can see there under My Stuff, it will have the slides that we're going over and also the replays for you. Make use of the group chat and the Q&A tabs along the way, because we have people in the wing that are answering chat messages or answering questions for us, and that is going to be super, super helpful. Also, you can see down there at the bottom, the link down below has the slides and replays ready for you to go as well if you want to click that link. And also, whenever we're doing our actual Cram session, we will take breaks. So the Cram sessions will be 3 hours long in the 5 days leading up to the exam. Tonight, we're just going to have like an hour just to kind of get a taste of what that might look like. But we will take breaks along the way for that. And the replay will be immediately available in your Fiveable account as well if you happen to miss a session or miss part of it. All right, so there's our schedule over there on the right, and then you can see all of our wonderful host and design team. Tonight, we have 2 wonderful student hosts who are going to be flying the ship for us, and I'm going to let them introduce themselves.
Hi guys, I'm Miriam. I'm also a high school student, so I'm really feeling AP season, but I'm really glad to be here. I love AP stats. I think it's just like a more fun math class, and yeah, really excited to be here.
Hey everyone, I'm Emily. I'm an 11th grader, and we're really excited to teach you guys AP stats, and I hope you guys learned something from us today.
Yes, woohoo! All right, I'm super excited. All right, so tonight our agenda that we have that we're going to be looking at, we're going to really focus tonight on the descriptive statistics part of the statistics course. So we're thinking more like units 1 and 2, 1 variable data and 2 variable data. So we also have a Cram quiz that we're going to do at the end that gives you some multiple choice, kind of fun trivia questions, and that will help you to kind of refresh your mind over all the things that you did probably towards the beginning of the school year. And then also we are going to premiere my favorite thing that I'm super excited about. PEP is going on Statistical Escapades over this Cram season. And we have some really fun free response questions that our design team worked on that is going to help you to review a free response question leading up to the AP exam. All right. And if you're kind of wondering like, okay, this is a preview night, but what actually is this cram mode that Fiveable is presenting? So the cram mode that Fiveable has, it gives you tons of resources. You have the prep books that are given that you can prep for different college prep classes like SAT, ACT, also AP exams, which is why we're here right now. You also have 24/7 access to over 200,000 practice questions that just a massive team of people have put together for all the AP subjects. And then also you will get tickets to all the cram events and the finales, which is the 5 nights of review leading up to that. So there's tons of resources that can help you to make sure you're successful on your AP exams as you're leading into that. So that's definitely something that you can take advantage of. There's a link down below that you can click and read more about that and go ahead and sign up for that as well. So some features in Crowdcast to go over before we really get into things. The first thing is we have the chat feature. If you look over there on the right, there's a toolbar, and I see a lot of people have already found the chat. In the very top, you have the chat option. You can chat with different people who are here, chat with different students. Also, you can ask questions there. If you have a particular pointed question that you want to ask one of the student hosts, you can always post a Q&A as well. And people can upvote your questions to make sure they want an answer to that. And then also we'll have some polls that we will put up throughout the night that can help you to engage, and we can kind of make sure that we're all on the same page with some of the main concepts that we're going to talk about. All right, make sure you follow Fiveable on social media. We have LinkedIn, YouTube, TikTok, Instagram, all the things. And there's lots of great resources on there as well. And also, fun social media type things that you can enjoy as we are all going through this AP season together. So every night before we start, we're going to kind of review what is on the exam. There is 2 sections in the AP stats. You have 40 multiple choice questions, which you are given 90 minutes for, and then you have 90 minutes for 6 free response questions. And tonight we are really going to focus on units 1 and 2, at least kind of a brief summary of units 1 and 2. And you can see over there that unit 1 makes up about 15 to 23% of the exam, and unit 2 makes up about 5 to 7% of the exam. So that is kind of our layout and our introduction for tonight. And now I'm going to pass the student host and jump right into the content.
Okay, so let's dive right into exploring one variable data, which, as we discovered, is like 15 to 23% of the exam. So it's like a big chunk. So this unit 1. Okay, so as an introduction to statistics, I'm sure you guys have all heard of this before, but statistics includes lots of collecting, analyzing, and interpreting data. So yeah, we're working with a lot of data and just figuring out how to make sense of it, since a lot of numbers doesn't usually make sense to begin with if you first look at it. And statistics is a great tool to use that can be applied to real world situations, and it's used in all sorts of fields. So like if you guys, I know somebody was mentioning data science, and it's becoming more and more relevant today as we live in a world of big data. And it can also be used for surveys, analyzing data, testing hypotheses, which is relevant to basically every single field. Okay, so first we're going to be looking at univariate data. So there's 2 types of univariate data. The first one is categorical variables, and the second one is quantitative variables. So categorical variables represents groups or categories, and they're measured in proportions. So some examples are eye color or a marital status. So if we're looking at eye color, for example, the different types of eye color is like blue eyes, brown eyes, black eyes, and then the way you would use numbers there would be the proportions. So how many people out of a population have blue eyes, for example, versus how many people have brown eyes. And since these are different categories, it's called a categorical variable. Quantitative variables, on the other hand, quantitative variables, on the other hand, are measured or counted variables, and they're measured in means. So some examples of those would be height or age. And as you can see here, they don't really have different types of categories for that or different numbers associated with categories. It's kind of just like, what are the different heights or what are the different ages? Okay, so this is just a check for understanding. So for each of these, you guys can try to identify whether it's categorical or quantitative. And you guys should see some polls popping up in order to do that. So for number of marbles in a bag, for class size, for hair color, and for square feet and population size, are they categorical or quantitative? Okay, yeah. So as most of you guys are putting these in, most of you guys are getting it right, which is a good sign. You guys are on the right track. So for the number of marbles in a bag, that's quantitative because we don't have like different categories for the marbles. We're just focusing on the number of marbles. So that's just like one number. So that's quantitative. And then class size is also a quantitative variable. But hair color has different categories like brown or black or blonde hair. So that's a categorical variable. And then square feet and population size are both also quantitative because you're measuring just flat out the numbers, not based on categories. Okay, so
I can take over on this slide. Okay, so now that we've learned about quantitative variables, let's start to show like how we can represent these in graphs. So a histogram is one of the most popular graphs for quantitative data. It's kind of like a bar graph, except bar graphs have gaps between each bar, and bar graphs are also for categorical variables instead of quantitative. Remember when you're using a histogram that you should label the x and y variables in their respective axes and use a scale that you can fit all the values into. For a stem and leaf plot, which is a little confusing, as you guys said in the chat before, it's another great way to represent quantitative data. We use the leading value for this graph right here, the stem and leaf, right under the picture right there. We use the leading value or the tens digit as a stem, and we write out the frequencies of every single units digit as a leaf. However, it doesn't always have to be just one value for the stem or for the leaf. For a value like 120, we could put 12 as a stem and 0 as a leaf. All that matters is that your key accurately shows how you can interpret your data. In this case, it would be 12, vertical line, and then 0. For a stem and leaf plot, make sure that you have a key so they can understand how to interpret your data. Okay, box and whisker plots. You guys were talking about these in the chat as well. They are another great way to represent quantitative data. There are 5 very important points on a box and whisker plot. So on the left whisker at the end on the right is your minimum value. This is usually literally the smallest value. Sometimes there will be outliers on either side, but usually this is the minimum value at the left whisker. Then there will be your Q1, your quartile 1, which is the median of your minimum value and your median. And this is the 25th percentile of all your data. Next, in the middle is your median. Your median is the middle value when all the numbers are sorted in an ascending order. If you have an even amount of numbers, remember it's the average between the 2 middle numbers. And on the right side, your Q3. Your Q3 is the median of the maximum and the median. No, what am I saying? It's the median of the maximum and the median and is their 75th percentile. And lastly, on the right is your maximum value and is the value at the end of the right whisker. You might be wondering what IQR is, which is Q3 minus Q1. And we'll talk a little bit about how you can use IQR to determine if there are any outliers on the right or left in just a couple slides. Okay, so AP statistics at the beginning is literally named descriptive statistics. So there's a lot of things you need to describe. There's a lot of things you need to interpret. So let's teach you how to what terms you want to use to describe these. So we have SOCS, which is our acronym that we use to describe each topic. So we have shape, outliers, center, and spread. So shape can be broken down into 3 different categories. We have symmetry, skewness, and modality. Symmetry is basically whether it's the same on both halves of the graph. So this is usually described as symmetric, approximately symmetric, or not symmetric at all. Skewness is the second one. It's a measure of the asymmetricness of a graph. And we can say a graph is skewed right, which means it has a tail leading off the right side of the graph. Skewed left, which means it has a tail leading off the left. What am I saying? Skewed right, which means it has a tail leading off the right side of the graph. And left is when there's a left tail off the left side of the graph. And modality is how frequent values are. So sometimes we have unimodal, which is kind of like a bell curve. It's high in the middle. Or we have bimodal, which is two humps. So it's kind of symmetric on the sides, but there's two humps coming in. Next, we have O, which stands for outliers. Outliers are data significantly different from other values, and they often mess up statistical measures. For example, if there's a data set of like 99, 100, 98, and then we have 50, many measures will significantly change, like the median, which is the average of the values, and then the range, which is the highest to the lowest. We can determine outliers using the 1.5 IQR rule or the two standard deviation rule, which we will talk about in the next two slides. And then next to center, we have the mean, median, and mode. So remember when you're taking a statistics test that median is the easiest one to use. So we usually always use this one. So mean is usually easily influenced by high or low outliers, and mode is not very accurate because you can have like 1, 1, 2, 3, 4, and you could say 1 is the mode, but that is definitely not the center of your data. So can we explain all the types of probability? We will do that at some point, don't worry. But once again, median is always the most important one. So you usually use this one. Mean is only good for when there's a bell curve or it's approximately symmetric. Okay, on to spread. It's a way to show the variability of the data. So there's three ways we can do this. We can do range and interquartile range, standard deviation, or variance. Range or interquartile range is calculated by subtracting the largest value from the smallest value, and that's range. Interquartile range is once again Q3, which is quartile 3, which is 75%, and then Q1, which is 25%. Standard deviation is the average amount of variability in your set, and this is one of the most widely used measures of variability. And lastly, variance is the measure of how far data points are from the mean. I can do this slide. Okay, so more on the shape of data. As I said before, we have the shape, which is symmetric, skewed right, or skewed left. So symmetric is basically the exact same on the left and right side. Skewed right is when there's a tail off to the right side. And skewed left is a negative skew, which means there's a skew tail on the left side. Uniform is when everything is about equal, so the frequency of just about every value is the same. Unimodal is kind of like a bell curve. It has one mode or one peak in the middle, and a bimodal has two peaks and two modes, which are approximately symmetric, but there's two modes instead of one.
Okay. Okay, so now we're going to be going over, like Emily already talked about this a little bit before, but mean versus median. So both of them are measures of center, but there's like specific cases when you would use one instead of the other. So we would use the mean. Okay, first, what is the mean? So we would add up all the values and divide by the total number of data points. And that's basically the average or our mean. But the problem with means is that they're easily affected by outliers. So because of that, they're only the best measure of central tendency when the data is not skewed and when it does not have outliers. So if it has outliers or it is skewed, we would not use the mean. But if it's symmetric, then we would use the mean. Okay, so the other alternative we have here is the median. So the median is the middle number of the data, and one advantage of using the median is that it's resistant to outliers. So that means that it's a better measure of center when the data is skewed or it has outliers. And also, one other thing about the median is that we would use it also when we don't know what the mean is. So for example, if we were just given a box plot, there's no way for us to find out the mean in that situation, so we would just use the median to describe it. Next slide, please. Okay. So here's just a few tips on how to determine outliers. So there's two rules that we use for how to determine outliers. One of them, we use the IQR to find out outliers. Another one is the standard deviation. So the 1.5 IQR rule says that values that are greater than 1.5 times IQR above Q3, so Q3 plus 1.5 times IQR, and anything that's greater than that would be an outlier, or values that are less than 1.5 times IQR below Q1. So Q1 minus 1.5 times IQR, anything that's below that would also be an outlier. So these are kind of like your fences, and everything outside your fences is your outlier. And then the 2 times standard deviation rule, for that, values that are more than 2 standard deviations above or below the mean are your outliers. And every time we're asked to describe a distribution, we should make sure to include a summary sentence at the end stating why we know that the data set either has or does not have outliers based on these calculated things. So even if it does not have outliers, we would still need to state, like, we know that because of the 1.5 IQR rule, or we know that because of the 2 times standard deviation rule, and then use like the calculations that we did to find out in our sentence.
All right, so for Unit 2, it's exploring 2 variable data, and this is about 5 to 7%, where we bring together 2 variables and show the relationship between them. Next slide. Okay. How do we show the relationship between 2 variables? So on the right side, we have this table of hours of sleep versus exams this week. And as depicted, we see that as the number of exams increases, the student gets a lot less sleep. So using our 3 describers, the strength, whether positive or negative, and linear or nonlinear, we get a moderate, linear, and negative relationship between the number of hours of sleep and the number of exams, which is exactly how you can describe it on the exam. Make sure you use all 3 terms so we can accurately describe the data. Okay, so how do we represent bivariate categorical? Remember, categorical, not quantitative. Quantitative will be on the next slide. So bivariate categorical data visualization. One way is side-by-side bar graphs, which compare the distributions between 2 groups and categories. Because they are right next to each other, it's very easy to tell which one's higher, which one is lower, and how big of the difference it is between the 2. Second, we have segmented bar graphs, which is showing burgers sold over the weekend when the graph itself looks like a burger, but that's okay. And by stacking them, it's possible to tell the proportions each one makes of the total and how big a proportion each one accounts for. Next, we have mosaic plots, which are 2-way tables where they horizontally and vertically add up to 1. So we can find the frequency for the pigeon color and the capture rate.
Okay, so now we're going to be looking at a scatter plot, which is a quantitative variable instead of a categorical one. So this is what we would use to represent bivariate quantitative relationships. So some things we need to know are what is an independent explanatory variable. So these are used to explain and predict the response variable. So it's basically like the cause, whereas the effect is either the dependent or response variable. You can go by either name, and it can be explained by and predicted by the explanatory variable. So we're predicting that the independent variable will cause the dependent variable, which is kind of intuitive. So in this graph, we're looking at a relationship between the hours of sleep and exams this week. And since exams this week is on the x-axis, it's the independent variable because we are thinking that exams this week will cause us to either sleep more or sleep less. And so exams this week is the cause, so it's the independent or explanatory variable. And then number of hours of sleep on the y-axis is the dependent or response variable because it's being explained by the number of exams this week. And another thing we need to do when looking at scatter plots is to describe patterns. So one of the criteria for describing these patterns is direction. So from left to right, if the y values are increasing, then that would be a positive direction. So if it's like going from the bottom left to the top right in that trend, that would be a positive relationship. Whereas if it was going from the left in the top to the right in the bottom, that would be a negative relationship. So basically we're looking at as the x value increases, is the y value increasing? If so, it's a positive relationship, but if the y value is decreasing, then it would be a negative relationship. Next, we're looking at form, which is the general shape or pattern. So here we're just going to describe either it's linear or nonlinear. We know that if it's nonlinear, there's different types and trends that it could be, but we're just going to see and identify whether it's linear or nonlinear. So if it's linear, the dots would go along a straight line. And if it's nonlinear, it could be curved, it could be all over the place, but yeah. Next, we're going to be looking at strength, which is how closely the values fit the pattern. So if it's stronger, then the dots would be closer together, whereas if it's weak or moderate, they would be farther apart. So when describing strength, we would use either of these three words: weak, moderate, or strong. Next slide, please.
We're going to take a minute to do the poll for slide 24. So if you guys go to the polls tab and you can answer the poll, we'll explain it after you guys are done.
Okay, so we just got a question about what extrapolation is. So extrapolation is, say we have a scatter plot and then it has a specific data set, and the data set starts at a specific value and it ends at a specific value, an x value. So if we have an x value that's outside of our range, either greater than the highest x value we have as part of our data set, or lower than the lowest value we have as part of our data set, then we can't use our linear relationship to explain it. Like, for example, if we had a scatter plot and we would generate an LSRL, a line equation for that scatter plot, but we can use that relationship to predict certain y values for certain x values. But we can't do that if our x value that we're predicting for is falling outside of the range of our data set.
Okay, so we have a question from Miguel who says, wouldn't the last graph just be no correlation? So the points are randomly scattered. So basically it's between no correlation and weak correlation. So there's basically no pattern at all. So it's weak. So it's not really none. It's more of a weak. We use weak, moderate, and strong to describe the correlations. Miriam, do you want to go over the poll? I think we have a good amount of answers.
Okay, sure. So the poll is just asking that if a scatter plot has y increasing when x increases, that would mean that it's a positive relationship. And R value of 0.2, we're kind of going to go over that in the next slide in a little bit, but that would probably be weak because it's a very low R value that's closer to 0. And a linear relationship, then that would be linear. So when we would describe it, we would say a positive, weak, linear relationship. Okay. I think we can move on to the next slide now. Okay, so we're going to now talk about correlation coefficient, or R. And it's kind of important to remember the word correlation coefficient because sometimes a question will just ask you about correlation coefficient or to interpret it without telling you that it's R. So first, what is R? Here's a formula of R. It's on the equation sheet, so you don't have to remember it. And most graphing calculators can probably do this for you. So you probably won't need to use the equation at all. What does R tell us? R measures the linear relationship between two variables. So it tells us how linear our relationship is. And the negative and the positive signifies the direction. So if we have a negative R value, that means it's a negative relationship. That does not mean it's less strong. It just means that it could be strong or weak, but it's the trend is negative. And then positive means a positive trend in our data. And 0, if we had an R value of 0, it would be no correlation to an R value, and it falls on a range of 0 to 1. So 1 would mean the points fall in an exact straight line, and 0 to 1 is the different magnitude. And when the values are closer to 0, or their absolute value is closer to 0, then that would mean a weaker relationship. And if it's closer to 1, that would mean a stronger relationship. So in our example, we were talking about an R value of 0.2. That's closer to 0, so that would mean a weak relationship. And here are some limitations of R that we just need to keep in mind whenever using it. So correlation does not equal causation. So just because our data falls in a linear relationship and it's kind of a strong linear relationship, that does not mean that our Y value is caused by our X value. So we need to be careful in the language that we use. And R is not resistant to outliers. So outliers can affect R. So if we want to get a more accurate representation of a graph, sometimes we would need to take out the outliers and then re-find our linear equation. And curved relationships can sometimes have a high R magnitude. So if we have the graph to look at, we would obviously need to double check. Even though we see that it has a high R value, we don't just assume that it's very linear, because curved relationships can sometimes trick us because they also have a high R magnitude.
Miriam, can you answer this question really quickly from nowhere?
Sure. So it's asking what R values are considered lower and what are higher. There's no like exact range. You kind of just have to think about it. But like usually if it's like 0.8 or 0.7 or greater, then that would be like a strong relationship. If it's like 0.4 to like 0.7 or 0.6, then that would be like a moderate relationship. And if it's below 0.3, then that would be a weak relationship. And that's talking about the absolute values of R.
All right, it's Cram Quiz time. So we're going to do a practice quiz. There's a QR code, and then we can also, I will send a link to the host to start the
It's the music. Yes, the music.
Okay, I will reshare the link for the Cram Quiz into the chat in 1 second. For this question, remember the 68, 95, and 99.7 rules. All right, so like 80% of you guys got that. That's pretty solid. So our common destructor was A. Okay, and then correct answer was B. Okay. So in statistics, the amount of points within one standard deviation is 68. The amount within two is 95, and then 99.7. So we wanted to know approximately how many are above the mean from one standard deviation. So 50% is from the bottom to the mean. And then we know 68 is contained in one standard deviation. So if we divide that by 2, we get 34. So when we add 50 and 34, we get approximately 84 percentile. Okay, we did slightly worse on this question, but that's okay. There's a lot of strong distractors. Okay, so our most common distractor was range, and then we have a little bit on A and we have a little bit on B. So the correct answer is C, which is standard deviation, because standard deviation works very well with normally distributed data, and the variability of ages among high school seniors is pretty normally distributed. So that's why it's C, whereas it's instead of D, which is very easily influenced by outliers. All right, so our third question, we have 65% correct, which is really good. And then our strong like distraction was C, which is 97.5. Okay. Our rules once again are 68, 95, and 99.7 for one standard deviation, 2 standard deviations, and 3 standard deviations. And since the z-score is between 2 and 3 standard deviations, we can narrow it down to either C or D. It has to be greater than 95. And then if we pull out a z-score table and you guys go to 2.25, you'll get that the number is 98.75, which is D. Okay, so we talked about shape and how to describe it earlier on. So you guys did pretty well. I'm pretty proud. So we know that skew left is when there's a tail to the left side. So it will be B, which is skewed left. Okay, obviously our distractor is going to be skewed right. So remember, whichever side the tail is on is what side it's skewed to. All right, so 91%, this is really good. Okay, so Miriam taught this one. So we know that when the R value can either be 1 or -1. So when, or like the highest R values can be 1 or -1. So when it's close to -1, that means there is a very, very strong negative linear association, which is B. So our common distractor is A, which says inconsistent effect. When the R value is very high towards 1 or -1, that means there's a very, very strong relationship. Ooh, okay. This one's a little harder. We have D as a strong distractor, and then A, and then a little bit of B. Okay, so an outlier is usually going to increase the overall R squared, but what if the outlier is like in the overall fit? Nothing will really change. So we need to take into account if the outlier is somewhat in the overall fit. So it's going to be B. It will increase if the outlier was reducing the overall fit, or decrease otherwise. So it's not D, because outliers will sometimes skew the results, but not always. All right, we're moving on to PEF's Statistical Escapades. Let's put up the A first. Okay, let's determine the 5-number summary. Remember the box and whisker plot for the data set above. right, so we have our 5-number summary. So if you plug this into a calculator, we can put this into like L1. We can plug it in as 3 zeros and then 5 ones, 2 twos, and then 1 3 and 1 6. So when you plug that into a calculator and you do one variable stats, you are going to get the minimum is 0, Q1 is 0.5, median is 1, Q3 is 2, and maximum is 6. All right, let's do part B. Describe the distribution of the inches in rain per day in Chilitown. All right, so as we said before, this is a skewed right graph because the tail is on the right side. The potential outlier is possibly 6. We haven't calculated yet, but we can declare it as a potential outlier. And then the number of inches, which is our range, can vary from 0 to 6. C, determine if there are any outliers. Use the 1.5 IQR rule to justify your answer. Alrighty, we'll do C really quickly. So there is one outlier. We will have an outlier on the positive side, which is 6. You guys already said that might be 6. Somebody asked in the chat just now, how do we know Q1 is 0.5? So we can input this data into a list on your calculator. So we go 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2, 3, and 6. And if you go stat and you go calc one variable stats, you can get the minimum, the Q1, the median, Q2, and then 6 as the maximum. All right, so using the 1.5 IQR, we get the IQR is Q3 minus Q1, which is 1.5. We multiply that by 1.5, and we get 2.25. Can you reveal the next one? Yeah, okay. So there are no negative outliers on the negative side, and there is one on the positive side, which is 6, because 4.25 is less than 6. So you can just say there's one outlier using the 1.5 IQR rule. Make sure you show your work. All right, our last part is part D. I will not read that all out loud because that is a full essay. And let's see if you guys can answer this one.
Okay, so for this one, the question is asking what is the error in his claim and how could he better represent our data set. So since our data set is skewed, using the mean to represent the center is misleading because it is strongly affected by outliers and skew. So like going back to what we were talking before about when to use the mean and when to use the median, we use the median when it's skewed or when it has outliers because the mean is very susceptible to being like misrepresented if there are outliers or skews. So the answer to the question would be the better representative for center would be the median, which is 1.
All right, before we finish, we wanted to know if you guys have any questions, final questions. We can answer them really quickly for you guys.
So the first question I see, how do we describe or talk about range when describing a histogram? So the best way to talk about that, and we had a little discussion on that in the chat, I personally would avoid the word range because range is a noun in the statistics world. So I always tell my students to say things like, the data varies from 1 to 6 inches of rain. If you're going to say the range, say the range is 6 inches of rain because it's that value of the maximum minus the minimum. So that's a really good question. That word range a lot of times is one of those little rubric things that the way the rubric team puts together for the FRQs, they want to dock you on, and we can think it's unfair all we want, but sometimes you got to play the game. And the best way I found looking at past rubrics to play that game is to say the data varies from 1 to 6, that type of thing. Another question we see, binomial probability problems. We will talk about binomial probability problems, I believe, on night 2 of the Cram streams. So come back and join us. If you're wondering where exactly you can join to get that call to action is now down below. So let's see. All right, so the printable notes, I will put that link back up as well. So that should be on the link down below. So let's see, I see another question. How can you explain how an outlier could possibly increase a correlation coefficient? So basically, it's really not going to increase it a ton, but if it is like, if you have a set of points down here that are all kind of correlated, and then you have another one that's like way up here, just 1 point, well, clearly that one's not like the other ones. And it's really not necessarily an outlier. It's more of a high leverage point. We kind of use the word outlier because it's not like the others. But in order to be an outlier in a scatter plot, it needs to have a larger residual than the other points. And if it falls on that line, it's going to have a pretty small residual. So really, we would say it's a high leverage point, which is just leveraging that correlation coefficient up, but it's technically not really an outlier because it does fall in that linear pattern. In fact, maybe even right directly on the line. But that is a really good question because we use the word outlier a lot just in our everyday vernacular, not necessarily thinking about the statistics behind what makes it a quote unquote outlier. All right. Also, I see in a lot of comments about where the different free response questions are going to be, like probability. That's everybody's stressor right now in these last few weeks. And it will show up more than likely on number 3 on the probability section. And that cram finale, we're kind of building the whole evening around what that free response section is going to look like. And the multiple choice questions we're kind of covering amongst all that. So we will very much so break down the structure of the free response questions, and you'll know going in, number 1 on free response is going to look like this, number 2 is going to look like this, number 3 is going to look like this, number 4, 5 and 6 are a little bit wild card, but we'll have a pretty good idea of what those might look like. All right, Emily, do you see any other questions? Maybe I missed some.
I see a couple in the Q&A that might not be answered. I'm not sure.
Okay. Go on and grab one of those and answer them while I'm flipping over there for that. Also, if you're heading out, make sure you take that survey down at the bottom for us. That'll be really helpful for us to make this cram season more beneficial for everybody.
I see a couple questions of how cram sessions and how some of the other sessions soon will be what we'll be doing. So we basically there's one about different sentence frames for interpreting R value, R squared, slope, y-intercept. We will do that on the cram nights, probably 1 and 2, where we'll be touching on like the earlier units. So yeah, we will teach you guys, especially on the FRQ Statistics Escapades, we'll teach you guys how to answer those formulaically.
Also calculator stuff. I see some questions on that. It's hard because everybody uses different calculators. And that's why I tried to help some people in the chat with calculator questions. My biggest advice for calculator would be whatever you put in your calculator, write out all the parameters and label them. So if you're doing normal CDF, label your lower, your upper bound, your mean, your standard deviation, and you should be okay. But we can go over those with some of the calculators that we'll do as well.
And someone asked, how do we put in our TI-84 to find R, like what buttons we click? So you want to input the data into a list first, if you guys can see. You input it into a list, and then depending on if you're doing 1 variable stats or 2 variable stats, you're going to go stat and then calc, and you're going to click either 1 variable stats or 2 variable stats. And once you input those X and Y lists or just an X list, if you do calculate, it will give you an R squared. So you can use an R or the R squared, and you can use that to interpret your data.
All right. I think that pretty much wraps it up. I mean, I would love to just sit here and talk about stats all night. It's my favorite thing to teach, my favorite thing to do. I don't get tired of it. So, but anyways, we will be back for preview night number 2 on Friday night, same time, same place. Cannot wait to see all of you again, and we will see you all next time. Good night.